Welcome to an introduction to Python. In this video we'll talk about lists. We'll cover lists, indexing, useful list functions, slicing, and list comprehensions. Python has several built-in container types: lists, tuples, dictionaries, and sets. We'll discuss lists in this video. A list is a type of Python object that can store a sequence of objects. The objects can be of different types. A list is created by using square brackets, and the objects are separated by commas. For example, I can create a list with an integer object, a float object, a string, a complex number object. We can access the elements in the list by indexing. Python uses zero-based indexing. That means that the first element is at index 0. It also allows negative indices, which starts from the back of the list. For example, -1 is the last element, -2 is the second to last element, and so forth. The len function returns the length of the list. So here's another list. If I were to print out the one at index 0, that's the first element. And I can print something at index -1. This should be the last element of the list, which is 5. And then the length of the list can be computed by calling the len function. In this case, there are 4 elements. So lists can be modified. It can be added to, removed from. The function append and remove allow us to add and remove objects. So for example, by the way, all these cells, when I create the variable x earlier, is still valid here in this cell, but just for sake of clarity, a lot of time I would just create a new list just to kind of be clear. Suppose I have this list, and I can add to it. For example, I'll add this string and then print it again. If I add, then it'll add to the end of the list. I can also remove. So say remove the number 3, then notice that 3 is gone. I can also call the pop function. If I were to call the pop function without any argument, it'll take out the last element of the list. Notice now high is gone. But if I were to remove by index, then I can also say, so for example, I can remove the first element by popping out the one at index 0. And if I were to print this again, notice then that number 2 is now removed from the list. You can iterate over a list by using a for loop. So for example, for each item in X, I can print out the item. So again, this is the X list that we created earlier. So we can use that for loop to go through each element of that list. And then if you have a list of numbers, it's nice to use the sum function to add up the elements of that list. So again, we have this list X. I can sum up the elements of X. So that sum is 22. Slicing allows us to access elements, access a subsequence or sublist from our list. And the syntax is we specify the start value, the start index, and then also the stop index separated by a colon, and it'll give us the list that start at start and then end at the one right before stop, so not including stop. And if the start and the stop values are not specified, Python uses default values: 0 for start and then the len for stop. So again, we have this list earlier. I can access a sublist. So if I do, say, 1 to 4, that means it's going to go from index 1 to index 3. So that's 5, 6, 7. If I don't specify the number 0, the first one, it will give us a default value of 0. So print out from the beginning up to index 3. If I don't specify the stop index, it'll go from the beginning to the end. We can also specify a step size. So start, and then the step size. The default step size is 1, and so if I specify a different step size, I can increment by another value. So for example, say I want to go from 1 to 6, and by increment of 2. So this will start at index 1, which is the number 2, go all the way to index 5, which is at the number 6, and it'll go by 2. And also if I specify a negative index, so for example -1, I can actually go backward. So if I were to reverse this, I'll start at 6, go back to 1, then this starts at the index 6, and then it'll go to index 1, not including 1, and it's going to go backwards. Sometimes we want to transform one type of data into another. So for example, if I were to have a list of numbers, we can create an empty list, and then we can iterate through the nums list here, and then as we iterate through it, we can add x square. So for every x in this list, we're gonna square and then add it to the new square list. So if I were to do that and then print out squares, I have the squares of the original list. Now Java allows us to do this even faster or more efficient by using list comprehensions. So we can do this by creating so again the nums. Well, let's do a new list here. We're going to create a list by saying I want all the x square for x in nums. So it takes every x in nums and then square it, and then I put that into a list. So this is list comprehension. So if for example, if I were to print out x, then I have the squares again, and this is a lot simpler than, notice, the previous code. We can also use conditions for list comprehension. So for example, if I want to create another list, but this time I want the square, but I only want the square for the x in the nums list if x is, say, even. So if I were to print this, then I'm only pick out for all the x in the list nums, only the even ones do I want to square. Okay, here are the references, and again, as always, as you download this notebook, there are exercises from my website. Thanks for watching.